Hi everyone, myself Satvik of branch CSC section C roll number 20951A05G4. The topic which I got for concept video for the data structures is comparison of time complexities of interpolation search and binary search. First, let me tell you what is binary search. What do we exactly do in binary search? In binary search, we search a sorted array by repeatedly dividing the search interval in half. Begin with the interval covering the whole array. If the value of the search key is less than the item in the middle of the interval, narrow the interval to the lower half. Otherwise, narrow it to the upper half. Repeatedly check until the value is found or the interval is empty. With this, we can actually divide in the array into smaller halves, so we will get less time complexity. Algorithm. The algorithm which we use in binary search is, in first step we compare x with the middle element. If x matches with the middle element, we return the middle index. Else, if x is greater than the middle element, then x can only lie in the right half of the subarray, as the array is a sorted one. After the mid element, so we recurve for the right half. Else x is smaller, recurve for the left half. Basically what we do in search, binary search, by example of a diagram. First, let us take 23 as the element which we have to search. First, we will calculate the middle element by using the formula low plus high divided by 2, where low is equal to 0 and high is equal to 9. We will get the middle element as 4. So, as the element in the fourth index is 16 and 23 is greater than 16, we will increment the L as m plus 1 and L will become 5 and H will stay at 9. And now the new index is 7th by calculating mid, and in the index 7 we have 56, which is, as 23 is less than 56, we will consider the left side of 7th index, and we will take high value as 6. Now the middle value will become 5. In the fifth index we have 23, so we will return the index 5 and we will return that 23 is found. This is the example of a program for binary search written in Python language. We will take the input parameters into a function, the array, the left, the right, and the key element which is need to be found. We will keep a condition if r is greater than or equal to L, which checks that whether we have uh, found the array or not found. If r is less than L, we can say that the element is not found in the array. So first we will find the mid value and we will check whether the mid value is equal to the key element. If it is equal to the key element, we will return the mid value. Else it is greater than the key element, we will increment the r to mid minus 1, and we will again use a recursive function, and if it is less than, we will increment the low value to mid plus 1 and we will call recursive function. Interpolation search. What do we do in interpolation search? Interpolation search finds a particular item by computing the probe position. Initially, the probe position is the position of the middlemost item of the collection. If the middle element is greater than the item, then the probe position is again calculated in the subarray to the right of the middle element. Algorithm. In a loop, calculate the value of pose using the probe position formula. Step 2. If it is a match, return the index of the item and exit. Step 3. If the item is less than ARR pose, calculate the proportions of the left subarray. Otherwise, calculate the same in the right subarray. Repeat until a match is found or the subarray is reduced to 0. The probe formula which is used to find probe position is low, which is the lowest index, plus x minus ARR of low into hi, which is the rightmost index of the subarray, minus low divided by ARR of height index element minus lowth index element. This is a program which is written in a Python language. In this function, we take the same inputs, that is array, lowest index, highest index, and the key element which is to be found. And we will check for the condition if the subarray reduces to 0, and if not, we will enter the if condition, and if the pose if the we will calculate the probe position, and if the probe position sat in the probe position, if the element is found, we will return the probe position. If the probe position is less than the element, we will call it recursively, and again we will find the probe position, and so on. Linear search finds the element in big O of n time. Binary search, dump search takes big O of root n time, and binary search takes big O of log n time. The interpolation search is an improvement over binary search for instances where the value in a sorted array are uniformly distributed. Binary search always goes to the middle element to check. On the other hand, interpolation search may go to different locations according to the value of the key being searched. For example, if the value of the key is closer to the last element, interpolation search is likely to start search toward the end side to find the position to be searched. It uses the probe formula, which has been already said to you. Time complexities. As you have already seen the difference between binary search and interpolation search in the previous slide, now let us see the time complexities of both the search techniques. Binary search. The best time complexity of binary search is big O of 1, and interpolation search is also same as binary, that is big O of 1. Big O of 1 time complexity occurs if and only if the middlemost element of the array is the key element. So as a binary search and interpolation search first starts with the middle element, we can say that its best time complexities are big O of 1. Coming to the average time complexities of binary search, it is big O of log n. Whereas for interpolation search, it is big O of log base 2 n. So the average time of interpolation search is less than the binary search. As interpolation search always using the probe formula, it always gets closer to the element, whereas in binary search it is not that possible. The worst time complexity of binary search is same as the average, that is big O of log n. Whereas for interpolation search, the worst time complexity is big O of n, which is greater than its average time complexity. So by this, I hope that you have understood what is interpolation search and binary search. So we cannot say that this is the best search technique based on your use, and you should use it properly and wisely. With this, I hope that you have gained some knowledge I would like to take leave from you. Thank you.